page 115. I am doing page 115. This is basically chain rule on trig functions and e to the u. Um, this is just saying use chain rule. That's all. All right, so let's look at this. So outside function is cosine, inside function is 5x. So when I take the derivative cosine is negative sine, keep the inside times the derivative of the inside, which is 5. This is bad form, right? Don't write it like that. So it's negative 5 sine of 5x. You can rewrite this without the parentheses if you don't want to draw parentheses there, but I suggest that you do. It keeps people from getting confused about what's going on there if you write your parentheses. Let's continue with this one. So g prime of t, derivative secant. Oh, so this is the most common one people want to screw up. So derivative secant is secant tangent. So secant, keep the inside, and whenever you write it, you keep the inside. So that 4t cubed comes for both places. And then take the derivative of the inside, which is 12t to the second power. Now, you do not have to take the derivative of that twice, because you're going back to the original. And this is not the best way to write it, so I'm going to put it up front. And keep this. All right. What in the world is that? All right. Okay, that's B. And C. So this is the same thing as tangent x to the 1/2. So y prime will be derivative tangent is secant squared of x to the half times the derivative of that, which would be 1/2 x to the negative 1/2, which would be, so the x to the 1/2 goes to the denominator, so square root of x, and that 2 joins it, and I have secant squared of x to the half. Now, some of you might be thinking, can I take this square, the x to the 1/2? No, you may not. That exponent is on secant. It's not on x to the half. That exponent of 2 is on the secant, not x to the 1/2, not the angle. And that's a fraction part of it. All right. D, all right, take the derivative here. So this is e to whatever, so you're keeping that e to the 5s to the 53. And take the derivative of the exponent. So 53 times 5 is what? 265? S to the 52. All right, that cleans up a little bit. Oh, actually, it doesn't really clean up at all. You just generally write everything in the front and then write all that stuff up there. All right, that's a mess. All right. E, okay, this is cosecant of x squared. So when I take the derivative cosecant is negative cosecant inside, cotan inside, times the derivative of the inside, which is 2x. Clean that up, negative 2x cosecant x squared, cotangent x squared. That's that. Continuing, y prime, derivative cos, let's do a rewrite first. This is cosecant x to the second power. So this is the chain rule, right? You might have thinking, because this one, well, that one had chain rule. So this one has chain rule. So I'll do the outside exponent first. So it's 2 times cosecant x, keeping the inside. Now I'll take the derivative of cosecant, right? The 2 minus 1 is 1, so I didn't bother to write the exponent. Now I'll take the derivative of cosecant x, which is negative cosecant x cotan x. You can simplify this. You can multiply the cosecants together. Let's bring the negative sign up front. So it's negative 2 cosecant squared x cotan x. All right. Continuing. Here, the square root's on the inside of the function, so it's sine x to the half. So y prime is cosine x, well, cosine of x to the half, right? We took the derivative of sine, which is cosine. We kept the inside. Now I'll take the derivative of that. If you haven't figured it out yet, it's 1 over 2 root x, right? Hopefully you've done enough of that derivative of that you can see that that's the pattern. And when we clean that up, it's cosine of square root of x over 2 root x. And no, they do not cancel. This is inside a cosine. This square root of x is not independent. It's not by itself. So these two do not cancel. All right, going on. This is the same thing as sine x to the half. So when I take the derivative, I bring the 1/2 over sine x to the negative 1/2. So that means it's 1 over 2 sine x, and that's under the square root, right? Negative 1/2 means go to the denominator. Remember, 1/2 means square root. So it's square root of sine x in the denominator. And I forgot the cosine x, right? The derivative of the inside, sine is cosine. So I have a cosine x in the numerator, right? This cosine x does not have a negative exponent. That's why it's in the numerator. Okay. All right. So this one actually has 3 functions. It's got sine of 3x to the 4th power. The outside exponent of 4 is one function, sine is another, and then 3x is another. So that's 3 different functions. Let's take the derivative, and hopefully I won't forget anything. So take the derivative. So the exponent first, 4 times sine of 3x to the 3rd power. Now the inside derivative of sine is cosine. And now take the derivative of 3x is 3. So we do 3 times 4, 12. There's no good way to do this. Right? This 3 is that exponent. Right? Final example on this page, y prime. So remember, this is the same thing as cosine t cubed squared. So again, there's 3 functions. The exponent of 2, the cosine, and t cubed. So bring down the exponent of 2. Cosine t cubed to the 1st times the derivative of cosine, which is negative sine, keep the inside of that, times the derivative of t cubed, which is 3t squared. All right, so that's going to be negative 6t squared. And everything else is the same. So it's cosine of t cubed, sine of t cubed. And that's page 115.